I didn't listen.
Hi, Paul. How do you upgrade OpenLineage Spark connector? Which version do you choose? Is it like we release and the next day you release it for your customers, or do you do some extra checks?
So we are using 0.18.0 version right now, and now we are planning to use latest one so that we can support for Spark 3.5 version.
Okay, how do you verify that the new version doesn't introduce any issues?
So we haven't started this migration till now, but we have integration test cases. So
you're
we will
hitting an
use.
interesting point though, because we are discussing between the teams currently how to do
How
that
do you know which
validation.
one is stable? Yeah, how can we market it?
No, what we will have automated. We have some automated testing, but we need to do more of that actually.
You just assume it's stable.
Yeah.
So the problem is once the jar is baked into the Dataproc images, it's very difficult to pull it back. Right, customers don't move on from that.
I can highlight one issue which I found in OpenLineage.
Okay,
Yeah, let's go for it.
let's go for it.
If we use BigQuery connector and trying to extract information related to BigQuery, then sometimes OpenLineage does not populate input and output field. And reason for that is OpenLineage is depending on BigQuery connector to get source and destination table name, and it passes Spark context to BigQuery connector. But till that time, Spark context is already closed. So that's why BigQuery connector was not able to send any information to OpenLineage. So there is a dependency on the Spark context. Because of that, this issue is happening.
Okay, I will repeat the question because I see Maciej is coming, and I know he was working on this. Maciej, we get the guy that's complaining about the BigQuery Spark connector, that the BigQuery connector needs to have an extra call to BigQuery to get some dataset info, but the Spark session may be closed at that point. Are you trying to reopen it? Because I remember last time you were touching this piece of code. You don't remember?
I don't remember. But please open an issue and I will look into it.
Sure, I will. Thank you.
Yeah, do that, Pulkit. That's
Yep.
that's the best way forward. Thanks. Okay, quick detour. Now coming back to the agenda. It's going to be Kuba talking about the Python operator now. Thank you so much.
I don't want this one. Okay. I'm not sure why it's showing like that. Maybe
I think
I can do that.
That's fine.
Okay. So my name is Jakub Dardziński. I'm from Getting Data. I'm the OpenLineage committer and let's say maintainer too. I also do commit to Airflow. Today I want to talk about extracting lineage from PythonOperator, which seems to be quite impossible. But let's see if we can find any solution. So first, it's identify the problem. So why do we even care about PythonOperator at all? And I have a question to you. How many of you have used Airflow and saw or wrote some Python method called with PythonOperator in production? So I assume that many of you. I can see, but I saw it too. And the reason is that PythonOperator is quite flexible. You can do whatever you want basically there with Python code. And yet there are 73 providers I checked it today, with over 800 operators total. Some of them don't work, are not up to date, or have some different purpose. We want to change something, and we write new custom operator or just use Python operator instead. And that's, I think, the reason for Python operator being the most popular operator still. And another reason is that Airflow also introduced TaskFlow API that lets you even easier cooperate with Python code and tasks and moving data around without dealing with XCOMs explicitly. So as I said, it allows you, the Python operator allows you to run any code, and that's the problem basically. So you can, for example, fetch the data with request library, then call some other DB client, upload it with GCS client, for example, then do something else. And well, if we want to integrate OpenLineage with all of these libraries, it's like basically impossible for us. We cannot analyze the code and say, hey, it's doing something, moving data from place A to place B. We cannot patch every library, keep it up to date. It's just impossible for us. So one thing that we could do, and it's kind of working, is to use TaskFlow API with Airflow datasets. So the code that is on the left might be replaced with the code on the right. So you can define dataset that has some URL or URI. You can use this dataset, move it around different tasks, and the lineage is generated. The task flow works in a way that inlets and outlets are generated for each of these tasks. But there are limits of that because it requires you to manually set up the Airflow dataset. Not everything can be expressed with Airflow dataset for now, and you need to split the whole work that should be done with the Python code just to generate lineage. And sometimes you don't want to split it because it's a one huge job that should be executed within one task. So before I propose a solution to the problem, I want to shortly talk about current state of OpenLineage in Airflow. So first version of OpenLineage provider was released on August 1st this year. It's an implementation of AIP 53 proposed by Julian Ledem, and it works with Apache Airflow greater than 2.7. It's a huge step for OpenLineage because it became a part of Airflow's code base. And relating to what Paweł said previously, with Spark, you need to deal with different versions of Spark, Scala, Iceberg, etc. We had the same issue with Airflow and Airflow providers. We needed to catch up with changes in BigQuery, with Snowflake, and other providers as well, and they patched the whole code just to make sure that it works. So now we are part of Airflow's code base. Whenever the tests in CI break after we add something new with OpenLineage, well, it breaks because we need to make something up to date. Shortly about implementation. So the idea is to have each operator exposing lineage themselves. The lineage contract is exposed by some data structure from OpenLineage provider. And for each operator, we can define get OpenLineage facets on start /complete/failure methods. so that they are executed before or after task execution. Here's the example for GCS to GCS operator. This is actual code. So it looks pretty simple, and it is simple. We just gather what has been defined as source and target objects and translate it to input and output data sets in OpenLineage. But this implementation in terms of PythonOperator has its limitations. First, it all happens on operators level, so we cannot intercept Python code. We cannot see what's really happening inside. And well, to remind you, PythonOperator can run any Python code basically. So just because we cannot go into the task execution within PythonOperator, we like to propose some other solution to have lineage collector, hook level lineage. The hook is optional here. I explain it in a moment. But the idea is to have lineage collector that is singleton instance, receiving information about inputs and outputs during tasks execution. So whenever we use some hooks or whatever that could send information about inputs or outputs, we collect it, and after the task execution, we can create and emit OpenLineage event as well. But this is not ideal still. It helps because we still need to find places and define some explicit calls to send such information. So for example, in GCS hook, in copy method, we could add to such calls to add input dataset and output dataset, and without using some other operator that makes use of this method, this copy method. But PythonOperator would use that instead. We would have this lineage information sent and emitted to OpenLineage. The other drawback is that you need to use Airflow hooks. So instead of requests, you should use HTTP hook, and etc. etc. I'm not really sure how many people use hooks instead of raw libraries, but like for me, at least, the benefit of using hooks is that it's well implemented yet already. You can use connections with all profits from it, so you don't need to deal with passwords, etc., because it's all contained in Airflow. But still, you need to do some manual job to rewrite the code for hooks. The other thing is that it doesn't necessarily need to use only hooks, Airflow hooks. So for example, I think Pandas is one of the most common libraries used in PythonOperator as well. So here's the example of hooking into the reading CSV from Pandas, getting the name of file name that of file path of this CSV file, and also reading the schema of the file straight from the Pandas attribute. So I prepared a short demo with something that would show such thing. So this is a simple DAG that just fetches the data from some public. Yeah, for all people, I can do that. Can you see it now? Okay. So you can. So the first task just retrieves the data from some public endpoint via HTTP hook, then saves it with pandas to some other file, and the other task just reads the file, selects some columns, and saves it to some other CSV file. So for pandas, well, this is pretty simple. It's just the POC, but I'm hooking into two CSV and read CSV methods, and I'm reading the file path and the schema. For HTTP hook, this is pretty simple because I'm adding the add input dataset line here only. So let's try to run the code using Breeze with OpenLineage integration. So it ran here, and what we would expect here is that the first task is getting the CSV file from HTTP, then it saves it to CSV with schema. It contains the schema. There is then another job that takes the first CSV file as input and uses the other as output with changed schema here. So this is short just to show that it might work. So this is under design, and for sure it requires core changes in Airflow. And because this is a core change, it won't be released sooner than 2.9. There is lots of things probably to be covered here. The other thing is that Airflow and OpenLineage datasets are kind of similar now, but they could be converged so that they could influence one on each other. So right now, Airflow dataset, whenever there is some event registered on Airflow dataset, we could emit some additional OpenLineage. Event, and in opposite, we could parse and create OpenLineage datasets as inlets and outlets, and let Airflow know that some dataset had been changed. So that would be bidirectional profit for Airflow and OpenLineage. There is also AAP58. It's an ongoing task as far as I know. The object store is a way to express datasets as light, let's say, interfaces, a table or file or whatever the place is, the object, and use them instead of using hooks or operators explicitly, just to move data around. So we would like to instrument this object store as well to emit the same data, also from PythonOperator as well. But PythonOperator is not the only one that can run arbitrary code. We have Kubernetes pod operator or Python virtual env operator, but this might be a bit harder. I'm just noticing that this is on the table as well. So that's it. And if you have any questions, I try to answer.
So thank you for talking. I have a question because you show us in this demo that you convert to CSV file. And can you show us what's inside the CSV file? Or just
I could. Sorry. I'm not sure where it is right now. No, I cannot.
okay.
Sorry, I don't have the path here. But why do you ask?
Just more interesting.
Okay, so you don't believe
What's
me.
inside?
But you can actually show the schema, right? You know what the format of the file is.
So it's just some IMDb database, as far as I know. So, sorry, I wasn't prepared for showing the data.
So, like, everything in Airflow, you have a lot of everything, a lot of operators, a lot of hooks, and you are probably going to address some of them initially to instrument them. Are you thinking about making it like easy for all the other contributors to make their own instrumentation to other hooks that are there? What kind of mechanism have you thought about?
What do you mean by easy?
Encourage, make it very straightforward, document, guide them. That's basically what I mean. I think that's like, if you really want to get like every hook in Airflow to be converted, you actually need to have this, that people will want to do it.
I would say that there are two answers for that. One is, yeah, it's pretty simple, because you should just find the place when the input or output is generated. So how hard could that be, right? But on the other hand, I know that there are some like discrepancies, like how do you know how to define what's the namespace or the name of the data set, right? That's something that we still need to work on to provide some better guidance, how to express data set in terms of OpenLineage. I think, well, it's not isolated to OpenLineage itself, because Airflow has the same problem, I think, because you can name data set with URI, whatever it is, right? But I think we need to standardize it somehow and converge, again, Airflow and OpenLineage datasets. We have some naming convention, but for sure it requires some more work.
If you need help, if you need help, I'm happy to. At the point when we start discussing things, to try to get some more help to encourage people to contribute.
Yeah, for sure. And I think we are close to like going public with the whole discussion. Yeah.
I just want to add that we might want to work from the opposite direction. And our idea is to have this whole like Airflow data system, OpenLineage, DAG, data-aware scheduling package so attractive to users that they will want hook developers to implement all of it. Because there are some efforts that are maybe too early to talk about, but basically combining all of it makes working with like pretty standard CSV, Parquet, stuff like that, data way easier than anything before, I would say. So the whole idea is that users will want to write this way. So yeah.
Yeah, but we can't really tell like what's the order, what will be released or not. So this is just some idea.
Just show a green light.
Okay, sorry. I might have missed something, but is there an effort, like how would column lineage work with, let's say, pandas? Is there any effort on tracking that?
I gotta be honest that pandas is only POC just to explore how to easily hook into these methods. Well, the best answer is to ask pandas developers to help us. I'm not sure how that would go. We can try, but I gotta be honest that I don't know. Like, I don't know how hard it is to track column lineage in pandas. Maybe it's easy, maybe it's not. Yeah.
Okay, thanks. I was just curious if anyone is working on that already.
Hey, so we've been showing HTTP example. How about some other hooks? Imagine like hooks based on some other protocols. Would the approach to implementing such lineage extraction be somewhat unified across different protocol types, or would it be, case by case, figure out what you need?
Honestly, I don't know. The reason I speak about it here is that there are some items that are brought up here, and it's good that we can discuss about it, right? Some of them are not clear. Some of them need some more discussion. And probably some of you think that, hey, this is stupid, maybe. So I just invite you to contribute, even if you just want to express what you feel about it. Maybe you have better ideas. I don't know.
No, I think it's a fair topic to discuss. Like once the discussion goes publicly, let's try to find some nice way to do it. Yeah.
So yeah, it's very early and we don't know yet what will happen, but one idea is that perhaps hooks will define, or like providers will define the actual dataset types, which will be those Airflow datasets that will be like easily convertible to OpenLineage datasets because we know what they are. They are not arbitrary URLs then. And then the hook will understand that in some ways, I know HTTP hook produces HTTP dataset, or GCS hook produces GCS dataset. Then, stuff like bucket and path in that bucket are understandable to it. So that's one idea how to do this. Basically, another like entity in the provider.
Yeah, but that's it. Work more on datasets rather than on hooks, I think.
Yeah, those who could emit those datasets, right? That's that. Still, you would need to instrument the hook, but you would know what kind of entity it produces, right?
Following what we are already doing in Airflow, so we could potentially have a check, like describe what you expect from given provider and given hooks are coming, as you said, and then make either even like some kind of automated way of previewing things that should be implemented there, or things that like how you are like what you should instrument, or just flagging that instrumentation is needed here to be done if it's not done. So that would be kind of guideline for people contributing. Okay, here, these hooks still need some love when it comes to integration with OpenLineage. Yeah. So I think this would be pretty doable, and following a lot of the things that we do in Airflow in the past, like how we were implementing this kind of bulk implementation of some idea in the whole code base. We could probably work out something like that. I'm happy to help with that.
Maybe one thing, right? And not everything has to have those data sets, lineage collection, because a lot of those operators aren't basically working on data, right? If something is creating a bucket or deleting your network in Google Cloud, it's not exactly a data operation. Same as like sending a message to Slack. So the pool is much smaller, and the pool that people actually use is even smaller. So the important thing is to focus on that.
Right.
Maybe, are there any more questions from the virtual audience? No? Okay, thank you very much, cool.
Thank you.
So next up is Big Lebowski again with how to contribute to Spark-OpenLineage. Go ahead, Paul.
Yes.
Hello again, happy to see you again.
And yeah, I think we do have like 30 minutes before going for a beer. By the way, who of you is willing to go? Yeah, we can go faster, much. Yeah, for you, we'll make it 15 minutes, and yeah, don't worry. Yeah. So the title is How to Become OpenLineage Spark Contributor. The initial title was In 5 Easy Steps. Then I realized that perhaps 5 is wrong. Then I realized that I'm not sure if the easy is the proper adjective to describe it. But yeah, let's go for it anyway. So the point is, yeah, the agenda for the talk is like, let's define the place where to start, how to start thinking as a contributor and trying to help the community. We can do a super fast code walkthrough through the submodules and projects and directories. We can say what are the ways of writing the test for the OpenLineage Spark integration, because we do write a lot of tests. And perhaps we could try to follow the path of a pretty common problem. I would expect different lineage event. What shall I do? And actually, there's a lot useful things you can do on your own. Yeah, and let's see this. So first of all, non-coding contributions are highly appreciated, and you can do a lot without writing a single line of code. So yeah, as you may notice, we're not English native speakers, and when we write documentation in English, it's perhaps not the best English. So, you know, if you just read the documentation, fix it, make it more readable and clear to others than we do, it's a great contribution. Anyway, if you are a developer and you implement a certain feature, your documentation won't be that good, because several things seem to be easy for you because you spent like a few weeks writing it, yeah? And someone else can do it better. So that's the first place. Then we do have a bunch of quick starts for OpenLineage Sparks, which tell you how to run OpenLineage Spark integration in Databricks, how to run it in Jupyter Notebook locally. And whether you prefer Jupyter local or Databricks, you can test it on your own. You can run it, verify it, have an opinion on that, perhaps find out some use cases that are not covered within our tests. Yeah, just playing around with a tool is really helpful, and it is still a contribution, I believe. And the other way to contribute is, you know, if you are doing some proof of concept within your company, you can write a blog post and just publish it with what you did, in your opinion, and feedback about the tool. And it doesn't have to be on OpenLineage site. It can be on Medium or wherever you have. And I believe this is still a contribution. So the contribution is not only limited to GitHub/OpenLineage. The contribution is whatever done publicly that is related to the project. And writing a code is just a small part of this. But today we'll focus on the writing the code part. So if you want to build OpenLineage Spark integration, you need to first build its internal dependencies, like the SQL Java and client Java. OpenLineage Java client is our client to emit methods from Java that we use for Spark and Flink, and actually you can use it for anything you want. And the first thing it contains code generator to generate Java classes from JSON schema. It was initially created by Julian because at that time there were no good tools to generate Java code out of the JSON schema. I don't know if there are such now. 2 years ago there were none of them. So we do have no, yeah. And for Python, Kuba, still not. What a pity. Even more no. Yeah. So in Java, we generate the OpenLineage code based on the JSON schema, and we do have a generator based on Java Poet for that. So, and this is the class OpenLineage that gets generated. It has like builders and useful methods to create whole events. Moreover, the OpenLineage Java client has transports implemented. The first one is HTTP to send event to the backend. the console, which is more for like testing purpose to see that you can, what events do you have, Kafka and Kinesis to send it to some message buses. I'm still thinking if Kafka transport is synchronous or asynchronous, because I believe you can pass any config options of the Kafka connector, Kafka client to it. And if you use Kafka, I'm not sure if there's an async version, but you can surely, mix with the acknowledgement level on the Kafka side. And if you reduce it, then it's almost like asynchronous. Yeah, so these are different transport types, and we do have also within this package a logic to read the transport configuration from YAML file or YAML objects in Java, and this is common for Spark and Flink. So in Spark, we have a logic that transforms Spark config to YAML objects, and this is read here. So the cool thing is that if you add any new option here to this transport, it will be automatically available for Spark. And if you want to modify something at the transport layer, you can just modify this package. And additionally, we do have a way of extending it. So if you do have your custom transport and you don't want to publish it to the community or release it, you can just have your own jar and define through the service loader the transport interface you want to use. And that's something someone was trying out. Then we have the SQL Java package that needs to be built. And the most important thing about it, it's not related to Spark SQL, although it's important to be built because it's a requirement. But it's more like for queries than within the Spark, you read something from or write to JDBC. And we do have an extra library that extracts lineage from SQL statements, from strings. It's called SQL Parser RS. It's the third-party library written in Rust. And perhaps Maciej can advocate why Rust is such a brilliant language to express anything you like. But it definitely makes sense here because we want to reuse the same for the Spark and Flink and Airflow world. So we want to reuse it for Java and Python worlds, and that's the beauty of Rust. Then that you can have a package and then wrap it for Java and Python and reuse the same code. Which is actually great. So this package, we do have a bundle over this library, and we extract SQL metadata from the query strings given. Yeah, and why is it so important? Because you need to build it first to build OpenLineage Spark. Code walkthrough, still 20 minutes to be here. If you have any question, just don't hesitate to interrupt me. But this is something interesting. It's amount of sub-modules we do have for Spark. So first one is the shared sub-module, which contains classes, common classes to be reused in other modules. And its main goal is we shouldn't have any Spark dependency here. Then we do have a bunch of models that depend on some Spark version, like the Spark 2 model, Spark 3, Spark 32, which is compiled with Spark version 3.2. And then at the end, we do have the highest package in the hierarchy, which is used to run integration tests on the top of all Spark versions that we have. And you may wonder, how is this possible? How can you write a code that will work on different Spark versions? Because in each Spark version you can have the same class with different methods, with different signature. And how can you handle it with a single library that is to be compiled against a specific version of the other libraries? And I'm not sure if you see it. But the only thing you need to see is the red box. Were you able to see it?
No.
No.
You can try.
Escape and zoom.
So just leave it. It's just this red box which says that you must trust me. I'm an engineer. That we do have builder factories that add certain piece of code, some visitors or dataset builders for specific Spark versions. And this red frame says that this factory builder is for Spark 3.3. Let me see if this is same. This is the same. No, we have to do something about it. It would have worked in Safari, No. Yeah. So what we do is we do reflection. Reflection is in Java is calling classes and methods by its name, by the string, and it's totally unsecure because it assumes there is such method and you assume you can call it. And what we are trying to do is we want to limit the amount of such code. And in this example, we know which Spark version are we currently running on. And then we create the dataset builder factory attached to this Spark version. And this allows us to have different submodules compiled against different Spark versions and still running correctly in the context of a single Spark version. Because if someone takes our jar and then it is going to be attached to a single Spark version that we don't know which it is, and it should work. Yeah, and reflection everywhere. It's not everywhere, but it's in some places. The entry point for the whole logic is the OpenLineage Spark listener. We just implement some of the Spark listeners, implements the Spark listener interface. And within this class, we determine if the execution context is SQL execution context, or is it more like RDD related job. And in most cases, like Spark SQL or data frame API, it is SQL execution context, and this one is called. Through the lifetime of the call that generates the OpenLineage event, we need to pass some OpenLineage details through all the classes, and we do have an OpenLineage context class for this purpose, which contains anything related to OpenLineage and this particular run. Like, for example, the run identifier that is generated at the beginning of the context being created. We also attach a Spark context to OpenLineage context. And yeah, in some cases, the Spark context can get closed, which was the question before the session. Sometimes we are trying to reopen it. Perhaps we don't do it all the time.
You can show it in.
Really?
Not showing.
Ja to znajdę w IntelliJ. Do you have any questions? Please give me a moment.
You're not sharing it.
I know I'm opening IntelliJ. It can take some time. I'm on the default points. I think I can skip this code part. So, yeah, we do have an OpenLineage context that just is a container of everything that we would like to pass to the methods we do have, so that the methods don't grow in the terms of amount of arguments being passed. And then we have OpenLineage run event builder, that class that initiates the event building. And it has different methods to populate, job, run, and datasets. And the main idea of this class is to traverse the logical plan to collect input and output datasets while using two approaches with query plan visitors and dataset builders, which is kind of the newer approach. Yeah, perhaps you can jump to test and see how to write a test, and there are different ways to do that. So unit tests are necessary, but are not enough, because unit tests don't like reflection. And moreover, oftentimes we read metadata from Spark classes, and unit test will not tell us if we read the properties, if the properties that we read are not null, if they really contain what we want. And integration test is the best way to verify behavior of a single feature. So by integration test, I mean something that runs real Spark, runs real data processing, and finds out if the lineage collected based on this was the one that we expected. And the first option is to do it in memory with in-memory Spark. So we run Spark session attached to Java test context, and we register a special event listener that stores logical plan of the last executed action. Yeah, so we run some Spark code. We see what was the logical plan of the generated by this. And then we test, so we trigger OpenLineage event building based on this logical plan, and we verify the event. And the limitation here is that it mimics the behavior of the complete events, because we just get the last logical plan, and it's difficult to verify for the start events. Yeah, I bet you don't see the code, but it's not important. You can go back to this once you go see the recording. The other way is you run Spark in memory, and you start the mock server to get the OpenLineage JSONs and verify if they contain what you want. And however, this is heavier and slower. And yeah, you can go even more deeper and write integration tests that are based on the Docker. So you do have JUnit test method that starts a Spark container with a specified PySpark script, which starts Spark container, and this container, computes some PySpark script. Yeah, while it is running, it emits OpenLineage events to mock server, and the JUnit test method is reading the logs of this Docker container, and at some point it finds out, hey, the processing has finished. Then it stops and goes to the mock server and verifies what events were emitted. Do they include what I expected? Yeah. If yes, it is passing. It can be extended. This approach can be extended even further to Databricks runtime. So with Databricks, there is a Databricks API Java library. It's released. It got released, I believe, in May or June, which allows you to spin up Databricks cluster with REST API calls. And this is something we are using in our JUnit test. So we use this REST API and Java client to make sure the cluster exists, to start the cluster, to make sure it has OpenLineage jar attached, copy Python script to the cluster, and run the job, which is the Python script. Yeah, once it is running, we use the file transport so that the OpenLineage events are written to a file. And at the end of the job, we copy the file with the events to DBFS, which is the file system that we can access from our JUnit test method. And then we fetch the events from DBFS and we verify if the events are the one that we expected. Yeah? Perhaps you can do similar for Dataproc to make sure that that the integration is working. And yeah, now we're moving to the final part. I would expect different lineage event, and that's the common case. I think it's like in dozens of issues. We can add a label like this, and the thing I would like to tell that in many cases one can do a lot on his own to help us and contribute to solving this issue. So first thing is reproducing the problem. You see the problem, and are you able to reproduce the problem with mock data and few lines of code? So if you observe the problem with your data set that has like 50 columns, I think there's a great chance you'll experience the same with just having 2 columns or 3. You don't have to copy and paste hundreds lines of Spark code because it doesn't help. Yeah. Yeah. The other thing is, are you able to reproduce the problem on local Spark Docker container? It's always easy for us if something is reproduced locally. So we don't have access keys to all the possible public cloud vendors. And if you experience some problem on Databricks, Azure, wherever, please verify if you see the same on a vanilla Spark run on your Docker within your laptop. And how to run it, you can see in the quick start section, because it's really helpful. And the rule of thumb is that if you want more people to work on a solution, you need to help them to understand the problem. And if you don't describe the problem well, the smaller amount of people will look into it. And that's obvious, I believe. Then, like in OpenLineage 1.4.1, we introduced a debug facet. And the purpose behind this was we wanted to let people enable just a debug facet that will contain as much useful and meaningful information as possible. And once you enable it, the facet includes some class path information. What is the OpenLineage library version? What Spark version do you have? What Scala version are you running on? What's the list of jars added to Spark? Some extra custom information on class path within the running job. So do you have Iceberg classes present on your class path? Which version of Iceberg package do you have? The same for Delta, the same for, I think, BigQuery connector. We also want to know what Java and operating system details do you have. And this is something that you can, enable out of the box with the facet and don't need to verify it on your own. The other interesting thing contained within it is some, shortcuts, some abbreviation of the logical plan, so that we'll know what's executed there. So we just include the list of nodes of the logical plan with a toString method of a node, so which tells us so the logical plan is the optimized plan of the Spark being executed, and we extract lineage based on the logical plan. It's a tree, and in general, the root of the tree is the output data set of the Spark job being run, and the leaves are the input data sets. And this plan can get big, and to get to know why the event looks like this, it's really important to know what plan has generated it. And we include it in the facets, yeah? And we do it in a lightweight version, so the logical plans can get big. We just take their names. And we also want to know the hierarchy, so we include some kind of pointers to identify the children and the parents, so that we can reconstruct the tree structure. We find it super useful because the name of the logical plan nodes really help to identify which classes of OpenLineage are used to create the lineage events. especially identified data sets. Yeah, so if you experience a situation where you think that the lineage event could be different, still you can write with a limited amount of code, you can be really helpful. So for example, you can write a failing integration test. And from my experience, being able to reproduce the issue is the most of the work. If you are able to do that, then the solution is in most cases not that difficult. If you think you do have an issue, please turn on the bug facet and try get its content. It can be useful. You can also prefer a fix with unit test attached, which is the super thing to do. But what I wanted to say as a takeaway of this story is that a lot of work can be done without coding skills. And this is something that is really helpful and is still a valid contribution to the project. So if you have an issue, try to describe it the best you can, then you just increase your chances of someone looking into it. Thank you. Do you have some questions?
You all want to go for a beer?
I'm on time.
Yeah, you're good. No questions. Any questions from the call? Look it. There you go.
Okay, my question is not related to Spark. It's related to Hive. So does OpenLineage support Hive as well?
So if you are reading a Hive table from Spark, then yes. But if you want to build lineage based on the Hive queries, like the Hive plugin, actually we haven't done this.
Okay, do you have any plan to support Hive?
So we didn't plan that. So far, we considered Hive kind of the legacy solution, with many companies moving to newer solutions. So I wasn't aware if there are a lot of people waiting for this feature. But I may be wrong. If I was wrong, then yeah, if the whole world is waiting for us, I would be happy to do it. But I didn't expect it like that before you asked.
That will be very helpful, maybe.
Yeah, Bulgar, we were already probing here. Let's probe more. Any other questions?
I saw that you use SQL parser in Rust. Any particular reason why you choose that parser?
Oh, it's a third-party open source solution library that was ready to use. And so the first reason is we would like to use it from Java and Python. And if it's something written in Rust, we can reuse it. That was the one point. The other point that it was really supported really rich syntax, and it had the capability to add dialects, like Snowflake has a different syntax, create stage, copy into. We were able to support it, and I must say it was. I'm not expert in many different languages, but I found it pretty useful, like the Rust in this context, because the SQL parsers library is well designed, well organized, and if you want to add something, you can look at different places that are similar to it, and with Rust you can express what you need with just a few lines of code.
But does it have many issues? I saw on GitHub it has over 100 issues open. Like, how stable is it?
Like
700.
Well, that's a different complexity project, I guess.
Maciej, take a microphone, please.
I think a lot of stuff is around supporting different, not even dialects, but particular database language constructs. Because there is SQL and there's SQL, and every database in the world has their own special constructs, special syntax, special stuff. And I think it's our approach is like 80-20. We have this support that works for 80% or maybe even more of the actually used SQL. And then we don't try to build a perfect parser, because we think that it should be closer to the database than reading inputs and outputs. And in some cases, like BigQuery, we are able to use this because it has an API. We don't have to parse SQL from BigQuery.
Yeah, but you mean like 100 issues for the SQL parser Rust library?
Yes, the library itself.
Okay, so yeah, I'm sorry, I haven't seen them, but the issues that I saw when I was working on it is like that some people like some syntax to be supported and they raise an issue, and it doesn't mean there is something wrong with it. It's just that they would like to have richer support. And of course, the amount of dialects and their syntax is pretty extensive, so there's no chance you will have everything there. But yeah, if you're interested in a single dialect like a Snowflake or other, there's a great chance that only some part is missing, and you can add it in a limited amount of time.
Thanks.
Maybe one comment. I think the main criteria when you choose library like that should be the community, not really the number of issues. It's more like how active they are, and it looks pretty good actually for this small library of this kind. It's like constant stream of commits, and like 5, 6, 7 people continuously contributing to it for 4 years. That looks like a healthy community from first point of view.
And it's very welcoming for contributions. So both me and Paweł has contributed something to it back, and we didn't have a problem to, get it accepted.
And a few months later, someone else was contributing to the same piece of code, and I was asked for a review, and it turned out it's a guy from Wrocław. So you can speak Polish to them.
Polish library.
Yeah.
Thank you very much, Paweł. Thank you, Mary, as well, and Kuba. And thank you, folks, for coming over, and also those dialing in. We're closing the meetup. Okay, Stefan, did you raise your hand intentionally? No, it was the wrong button. Okay. Thank you for dialing in. Hope to see you soon again and talk to you again. Yeah, thanks everyone for coming. There are some goodies in the back over there for folks. If you want to grab a bag, feel free. And we're going for a beer now to Uwaga Piwo, Fabryka Noblina. So we will meet downstairs, outside, and walk over. I think it should be, it's really close, 5 minutes. It's not even. Ciao, folks.